two identical isolated conducting small spheres are placed with their centers r distance apart. One is given a charge of 2q and the other a charge of negative 3q. Find the magnitude of electric force exerted by one sphere on the other. As shown here, we got 2q, negative 3q, and the distance r, and the force in between F1 and F1. Now we write the magnitude of force F1, K modulus of 2q, modulus of negative 3q over distance square, r square, equals 6 times kq square over r square. So we name this kq square over r square as general F. Therefore, it becomes 6F attractive force. Now the next, the spheres are connected to each other by a conducting wire for a moment, which is then removed. 2q plus negative 3q, that gives us negative q, and we distribute this total charge equally because they are identical spheres. So the spheres are connected to each other by a conducting wire for a moment, which is then removed. After you remove, they are placed with their centers r over 2 distance apart. Let's show that r over 2 distance apart, because the conducting spheres are now carrying negative charges. The red arrows are shown outward, which means repulsive force. Let's calculate the magnitude of this repulsive force. Magnitude of F2 equals K modulus negative Q over 2 times modulus negative Q over 2 divided by distance is now R over 2. That's why R over 2 square. After simplification, we have now K times Q square over 4. 2 times 2 is 4. And then R square over 4. That simplifies to K Q square over R square. Again, like above, we call this one K Q square over R square, like we did above, F. Therefore, the result is 1 times F. Now we have found the electric force between the two after they have come to equilibrium as F repulsive.